Hello, everyone. Anna, welcome to PyCon. Anna is a software developer and maker. She enjoys developing and facilitating workshops. Thank you so much, Anna, for that. And she's an organizer of Notebots AU, a co-organizer of Brisbane IoT meeting groups, and an author of Make, JavaScript Robotics. So it's a pleasure to introduce you, Anna. Thank you so much. Now over to you.
Thank you. All right, so you've already seen some of what MicroPython can do. So my talk is really much more simple. It's how you would get started with developing IoT devices using MicroPython. So just some more background about me. So I am a senior Node.js developer at Console Connect, so I apologize if some of my Python is not quite idiomatic. But I do teach Python. I teach a Saturday robotics class with kids, and I run workshops using Arduinos and various other devices to teach robotics and Internet of Things, both with MicroPython and with Arduino IDE. So I'm a bit of a maker hobbyist. And the project that I'm going to be drawing some examples on today is just the one that's pictured there. Unfortunately, the robot did not survive in my suitcase very well on the trip from Brisbane, so it may or may not work. But what it is it's a little pet that is there to remind me when I need to do exercise, and it kind of nags me, and then I can press a button and let it know that I've actually done the exercise. So a very, very simple IoT demo device. So I thought I'd talk through a bit of the process that I go through when I'm developing my hobbyist devices. So I guess the first thing to do is kind of look at the requirements, what you want your project to do, and then to choose the architecture, select the language, and the development tools, as well as the hardware based on those requirements. So for a lot of the really simple sort of projects, like this pet, for example, the architecture is not going to be very complex. It's going to be one or two devices, probably not very intelligent devices, mostly just gathering data from sensors or with some very simple actuators like some LEDs or something like that. Most of the work is going to be done by a cloud service or an app. So that will affect your choice of hardware. So once you've done that, pick some hardware. I'll talk a little bit about the hardware that I've chosen for this project. Write some programs to read from the sensors, control the actuators, and then develop the communication between what's essentially a very dumb device with the applications that are running in the cloud that are actually doing all of the processing and the analytics on that data. So a lot of IoT is really there to get some actionable insights out of your data. So analyze that data, do something with it. So in my case, it'll be analyzing how much I've exercised and then work out how frequently it needs to nag me to actually get me to exercise. So MicroPython, Damien's already covered this, but the reason I chose to use MicroPython was that I was teaching a lot of classes using Arduino IDE, and I was already using ESP8266-based microcontrollers. And I found that because the students that I was teaching had already been exposed to Python, that MicroPython was a really intuitive sort of leap for them. So trying to teach them some of these concepts using C++, C in Arduino IDE was quite challenging. So I started using MicroPython for my classes, and then I thought, well, why don't I start using MicroPython for my own projects? Because it's really making things a lot simpler, more intuitive, a lot faster to develop. So Damien's already covered what MicroPython is, basically a version of Python for constrained environments, particularly microcontrollers. And the thing that also really appealed to me is it's open source, and there's a lot of really great documentation and libraries available for it. So selecting hardware, there is a lot of hardware that's supported by MicroPython. So these are some examples of some of the ports. The hardware that I chose to use for this project is the ESP8266. And the reason that I chose that is just because in the hobbyist community, it's pretty ubiquitous. A lot of the projects that you used to build on, say, an Arduino with a shield, like an Ethernet or a Wi-Fi shield, a lot of people are now using ESP8266-based microcontrollers just because they're so widely available. They're really well documented, and yeah, they're really quite inexpensive as well. When it comes to the ESP8266 microcontroller, there are lots and lots of different dev boards out there that you can choose. These are the three that I typically go to for my projects. So there's the Adafruit Feather Huzzah, ESP8266, the Wemos D1 Mini, and the Node MCU version 1 microcontroller. And these are all very, very similar development boards. They all have, obviously, onboard Wi-Fi because they're ESP8266 based boards. They all have up to 4 mega flash. The modern versions of them all have 4 mega flash, 80 megahertz processor. They all operate on 3.3 volt logic, which is a little bit different than, say, if you're coming from the Arduino world, which is typically 5 volt logic. So you have to sort of adjust some of your circuits and programs to cater for that. And they have a decent number of digital I/O pins, up to 11. I think one of these devices has 9, and one has 10, one has 11. They only have one analog, one ADC pin, which is a bit of a limitation if you're doing stuff with a lot of different analog sensors. But for a lot of my really simple projects, I really only want to deal with one sensor at a time. And then you can also connect more sensors using something like an I2C bus. So you can work around it, or you could connect an external ADC if you wanted to. So I found these to be really great for hobbyist projects and for developing prototypes because you've got, a decent number of pins exposed there. And they're all designed to plug straight into a breadboard to make it really easy to work with. They do also all support ITC and SPI. Unfortunately, there's only software ITC on these boards, but that's good enough for prototyping. And the board that I'm using today is the Adafruit Feather Huzzah, purely because it's got an onboard lithium battery charger, which just makes it really easy if you're developing a small standalone device. You can plug the battery straight in. It charges through the micro USB cable. So that makes it really useful for prototyping without having to worry about power requirements. So this is what the pin layout looks like on that particular board. I apologize, it's probably not very readable, but this is pretty indicative of the others. You've got a number of I/O pins down one side, and on the other side you've got things like your 5 volt and your ground and that sort of thing. So the typical process that I use when I'm working on developing a project, first of all, I work out the interactions. So Internet of Things devices, the ones that I build anyway, tend to be very interactive, and they're designed for demonstrating or for working with students. So I think about the way that I want it to work and what I want it to achieve. So for this particular device, it's very simple in terms of the circuits and the code, but really the interactions are the important thing. It needs to be kind of cute, and it needs to have personality so that it will actually engage with me and make me want to do my exercise. So once you've designed the way that you want it to feel and look, I guess, then you work out what components you need and what board that you need. And then the process that I use is I typically design my circuit, which is just plugging in the different components, which pins I want them to go on, and then write a program for each individual component and get that working independently. So sort of a modular approach. So for this particular project, which has a buzzer, a button, and some LEDs, as well as a screen, it would be developing the programs for each one of those, and then having functions for the, what I want to display on each one, or how I want it to interact for each one, and then work on developing the program that actually does the communication up with my cloud service or whatever I'm running on the back end. And then finally use the REPL to interactively tweak. So one of the great things about MicroPython is it does have that interactive read-eval print loop, so I can go in and I can work out exactly what timings I need or exactly what colors I want to display on the LEDs, that sort of thing, without having to, say, in Arduino, where I'd have to go and compile it and upload it, and it would be a very slow process. Being able to do that pretty much instantaneously really cuts down on the prototyping time when it comes to designing those and developing those interactions and behavior. So for this particular project that you can see here, this is the circuit. So it's really simple. It's only a few components. There's a 12 ring Neopixel. There's an OLED screen, there's a button, and there's a Piezo Buzzer that just beeps so that I'm forced to pay attention to it. So what I'll do is I'll just step you through basically what I did for each one of those components and how I put it together. So the first thing I did actually was I developed the shell for it. So this is something that I just threw together in a 3D modeling program. So this is what it looks like on the inside. It's not a telephone, it's the Neopixel. And you can see the 3D model for the case on the outside. So this is kind of the shell here that's got the OLED screen on the inside with appearing as eyes. And on the inside, we've got the Neopixel and the button and the buzzer. So before you actually put it all together, though, you need to make sure that you've kind of hooked everything up and prepared the board, because you don't want to have to be doing things that involve having to unplug everything once you've got it in the case. So this is all coming pretty much from the documentation for MicroPython, so I won't talk through it in a lot of detail. But it's really, really simple to get it up and running. You pretty much just install whatever drivers you need to talk to the board, USB serial drivers. Make sure you've got the ESP tool installed on your system. And then you can use that ESP tool to erase the flash if you've used it before. So I quite often recycle these from various projects. So they might have had some Arduino IDE code on them. They might have had Lua Node MCU environment on them. So flash it to make sure everything's nice and clean, and then upload the latest version of MicroPython, which you can download from the GitHub pages from the releases. So yeah, really simple. Once you've done that, you're pretty much ready to go. Then connecting to the board, I prefer to use the command line. I usually just use screen from my Mac to connect. So just a matter of connecting at the 115/200 baud rate. And then when I'm doing things interactively, what I'll do is I'll develop the code in, say, Sublime Text, and then I just paste it across into my terminal using Control-E to enter paste mode with MicroPython. And I'll demonstrate this in a minute, just talk through it first. And then if I write longer files that I don't want to paste in, I upload them using the AMPY tool, which is from Adafruit, which I find really useful, particularly for loading up libraries onto the board. When I'm working with students, though, I tend to use the WebREPL. So that's the WebREPL there. You can pretty much connect to the board. So if you've got it set up as an access point, you can connect directly to it. Or if you have it set up to connect to your Wi-Fi network, you can just go to the IP address, and the port is 8266. Access it via the WebREPL, which just gives you a nice interface like this that lets you type in code. So that's your REPL on the left-hand side, and it gives you a really simple way of uploading the files as well to the board. If you are using that, though, originally it used to be enabled by default, but now if it's not, for obvious security reasons. So if you do want to use it, you just need to make sure you import the WebREPL setup and then enable it on boot, or if you prefer, just import it as you need it and start it and stop it directly from the REPL. So when you do set up your device at first, it will be set up as with an ad hoc Wi-Fi network, and the default password is MicroPython with capital N. It's a really good idea to change that. So especially if you're coming to something like this, so that someone doesn't hack into your device while you're in the middle of a demo. It has happened. Yes. So yeah, this is how you do that. You just set it up in the main.py and upload that onto your board, and yeah, then you're good. You've at least got a different password. Probably can still hack into it, but might take them a bit longer. So that's getting set up. Developing the programs. So I typically start with the simplest things. So in this particular example, it's the button. So a button just needs 2 wires. I've got mine connected up on pin 12. It's just ground and pin 12. And it's super, super easy to get this working on MicroPython. So you pretty much import the machine library, or indeed just the pin class is all we need in this case. Set it up using the pin class on the pin that you want, so pin 12, tell it it's an input mode, And I've also set it up with the additional parameter to tell it to use the built-in pull-up resistor on the board because I didn't want to have an extra resistor in my circuit. I don't have a lot of space in there. And once you've done that, you can just get the button value using button.value. So if you want to do something in response to that button press, well, the simplest way to do it is just to poll the value of the button. So just setting up a loop, taking a reading. It's always a good idea to take a couple of readings to compare. And then, yeah, pretty much can just use that to work out when the button's pressed and when it's released. So you can do a really similar thing with analog sensors. I don't have an analog sensor in this particular example, but if you are using an analog sensor, you just use machine.adc instead of using the pin. So very, very simple. The only gotcha on these particular boards, the ESP8266s, is that you can only have a 1 volt voltage on that pin. So if you are using a sensor that you've, say, taken from an Arduino kit or something like that, you need to make sure that you have set it up with a voltage divider so that you don't destroy your board. Okay, so that's a button. A buzzer, also very simple, 2 wires. I've got mine plugged into pin 14. And again, really, really simple stuff. This one's a bit different because rather than just being a digital reading on or off, this is actually an output device and I'm writing to it. So you can write to a digital pin using high and low or on and off, but you can also write using PWM, pulse width modulation. So for something like Piezo Buzzer, if you wanted to play different tones, you'd set it up so you still import the pin class, but also import PWM. I've set up just a couple of different notes. These are just the frequencies of those notes. And then set it up on pin 14 in output mode. And then it's as simple as just using the frequency, so piezo.freq, to play the tone. And then finally dinit, because as soon as you initialize it, it will start making noise. So this is not one that you want to do using the REPL necessarily, because it's just going to be squealing the whole time. And when you have a whole class of kids doing that, it gets a bit, a bit old. So yeah, make sure you have that dinit there in the end. One of the components that's really, really popular with the students that I teach and that I love putting in my devices are Neopixels. So this is Adafruit's marketing term for the WS2812B light source, which are pretty much just extremely brightly coloured addressable LEDs. And they are awesome. They come in lots of different form factors. You can get them in strips, you buy by the meter. You can get them as individual components. You can buy them in these rings or in the bar form. And these can be, in theory, they need 5 volts, but you can drive them off 3.3 volts, which is great because you don't need an external battery if you're using only a small number of pixels. So I've found pretty much up to about 30 or 40 pixels is usually fine on just coming off the microcontroller pin. Once you get beyond that, you want to add some batteries. So you can find out all about them on the Adafruit website. But they're really, really easy. They're pretty much designed to run off a single pin. So you've got your power source and your ground, but then you connect a single digital I/O pin to any number of pixels. And you can chain them together as well. So each ring will have an out pin as well that you can chain onto additional rings. So if you've got a project that needs to have lots of pixels, you connect them that way. Now, there is a built-in Neopixel class in MicroPython, which is why I really like using these. It's very, very simple. So you can just import the Neopixel class and the pin class. So you set up the pin first as an output pin, and then you set up the Neopixel class to use that pin, and you tell it the number of pixels that you want to control. And then it's as simple as just sending a tuple of RGB values, red, green, blue values, to a pin, to a pixel within that. So this is an example of just some really simple code that I wrote that will pretty much iterate through the pixels, and for the Neopixel at that pixel number, it'll set it to a particular color. So it's just going to set them all to be a particular color or clear them by setting the values all to 0. And obviously you can do much more interesting things. You can set different colors, you can have animations and that sort of thing. So those are all built-in libraries. One of the really cool things about the MicroPython ecosystem is that there are lots of third-party libraries as well. And I found the ones that Adafruit develops to be particularly cool. They already had a lot of libraries that I was using in Arduino sort of C land, and some of them have been ported across to MicroPython. So one that I was using for the screen and the eyes here is the SSD 1306 OLED library. And pretty much getting that working, you just go and grab the MPY file from the repository and then upload it to the board using AMPY. And this is an example. This screen is an I2C component, so it's an example of using I2C. So you import the library, set up the I2C component using the I2C class, and just for backwards compatibility with Arduino. So not sure how many of you are familiar with working with Arduino, but typically on Arduino, analog pins 4 and 5 are the pins that are used for I2C. And although technically you can use any of the pins on the ESP8266 for I2C because it's software I2C, by convention, pretty much everyone uses 4 and 5. So you set up your OLED display using that I2C class, just telling it the dimensions of the display, and then you're ready to display. So very, very simple to get up and running with third-party libraries as well. But once you've got all those bits and pieces all kind of doing something, what you want to do is to be able to pull it all together and to actually get it talking to something in the cloud. I mean, it's Internet of Things, so we need to have the internet component. By far the simplest way to get that up and running is just using HTTP post requests. So run a really simple web server on the ESP8266 and talk to that. So this is an example, and I'll actually do this as a demo. Hopefully it'll work. An example of a basic web server based on one that was sort of, I think it might have been one of the Adafruit examples. So you pretty much have the HTML that you want to display. And we've set up the Neopixels, and we've got that color wipe function that we saw just before. And then to kind of pull this all together and make it a network-enabled device, we just use socket modules. So pretty much just a loop that reads the requests as they come in and is looking for just a particular string in that request. So it's looking for Neopixel on or Neopixel off. And we'll simply respond by turning the Neopixels on or off, just to a single color in this case, based on whether or not that's in the string. So let me just show you that working. Live demo, hopefully this will work. All right. Yep. All right, this is the one I've got connected. I apologize, I have way too many terminals open. Go away. All right, so this one, let's just check it's still alive. Yep. See if I can zoom in on that a bit. Good. All right, so this is the MicroPython REPL. And to run that web server code, what I'll do is I'll just go grab it. I've got it set up. I did have it. Let me just find it. That looks like it there. So all I do is I could upload that as a file, but I'm just going to copy and paste it straight into the REPL. There it is. So hit Control-E and you go into paste mode. Paste that in, and then Control-D. Oh no, I forgot to import the library. Let me just go and check. Yeah. Let me just go grab that from there. That's why you should not do live demos. Oh, hang on, machine.pin. I probably edited this just before. Yep, thank you. All right, let's try this. Okay. Control E. All right, so now that's running as a web server. And what I will do is I'll just go and I'll join that access point, which is right there. And if I go to a browser, let's just open this. 168. Now, by default, it will be on 192.168.4.1. Yes, good. So I should, in theory, be able to hit the on and off button. And it's not working. These would be red. Live demos. Yes, so anyway, that does work when the robot is not broken. Oh no, time is not. Seriously. Okay, that could be why. Try that again. Oops. Be back. Oh yeah, Control D, thank you. Oh yeah. Okay. Try this again. So this is how you connect. tty.slab, yep. Control E, Control D, fingers crossed. I'll only try it one more time. Right. Yes! That's why I was changing them to blue and I must have somehow messed my code up. Should have stuck with the red. All right, I thought it looked angry. So, okay, that's how you do a web server. I find that basic HTTP web server kind of approach works really well for demos and for prototyping, but if you want to integrate with kind of the wider Internet of Things world, you should probably use MQTT or something like MQTT, so very simple messaging. This is an example of a really simple MQTT program that pretty much sends the button events to a server. So this is what I would use to notify that, yes, I have indeed done my exercise. So you import the MQTT, which is built in, and there's some examples that you can find that do stuff with JSON and putting in a JSON file and automatically writing it and loading it in on start. I highly recommend you do that. I couldn't fit it on one slide though, so I got rid of all of that. But it works the same way, so it has all of your configuration in terms of which server and which channel, which topic you're using an MQTT. So it's just pub sub. So in this case, it's like my button code from before. I'm getting the button value, getting a second reading, comparing that to work out if I've actually got the button pressed. And if it is, then I'm publishing that button press event. So let me just have a quick go and see if this can actually run very, very quickly. Get rid of that. All right, so that would be, need to actually make sure I'm running an MQTT server. So I'm running Mosquito here on my local laptop. And in another terminal, I would need to have a Mosquito client that's subscribing to the button events. So hopefully everyone can see that. And then finally, I need to have my MQTT program running here. And then let me go back to that other window. Hopefully when I press the button, yeah, it's getting pressed events there. So this is not very impressive because this is kind of what's happening on the back end, but you get the idea. You could have it storing in a database or doing something cool. So there's that. And it's super, as you can see, super easy, much easier than the web server to get right. All right, so there are lots of other languages you can use for doing this. So Lua, Arduino, Espruino JS, for example. But I really like using MicroPython because the code is really clean and intuitive, excellent for teaching students who are already using Python. And as I said, that interactive REPL, you can't beat that for just working out what you're doing in terms of the interactions. And the other really cool thing that I think is going to be big is edge computing. That's the idea where you do your processing as close to the data collection point as possible at the edges of your network, so on the board or on a gateway device. And we all know that Python is awesome for doing data processing and that sort of thing. So I think there's really going to be great applications for edge computing with MicroPython. I've run out of time, so this is where you can find out more. My blog, on Twitter, or yeah, the MicroPython documentation is awesome. So thank you very much.
Thank you, Anna. That was a wonderful talk. And I'm sure your students enjoy it as much as we did.
Thank you.
There's a 10 minutes break now till the next one starts.